Hello everyone, and welcome to Ninja Math. Today's mission is to master two-variable inequalities. After today's mission, you should be able to graph inequalities on coordinate axes with labels and scales, and create inequalities in two variables to represent relationships between quantities. Now then, let's get started. Some key words we should know for this mission are linear equality, an inequality in two variables whose graph is a region of the coordinate plane bounded by a line. A good example of a linear inequality is y is greater than or equal to 3x minus 1. Our next word is boundary. A boundary is a line in the coordinate plane that separates the solution of the inequality from the non-solutions. The boundary will be dotted if the inequality is greater than or less than, and it will be a solid line if the inequality is greater than or equal to, or less than or equal to. And the last word is half-plane. A half-plane is a set of points in the coordinate plane that are on one side of the boundary of the graph of a linear inequality, represented by the yellow shaded region on this graph. To determine which half-plane to shade when graphing, pick a test point that is not on the boundary and plug its values into the inequality. If the test point works, then you shade the half-plane that includes the test point. If not, shade the other half-plane. Some good test points to use are 0, 0 or 1, 1, as long as they are not on the boundary. First, in problem 1, we must locate the enemy, so let's begin. The enemy has been spotted in a location represented by y is greater than or equal to 2x plus 4. Graph their location on the coordinate plane. Our first step in solving this problem will be to graph y is greater than 2x plus 4 as if the greater than sign is an equal sign. Y is greater than or equal to 2x plus 4, so we use a solid line for the boundary, like below. Here is the graph of y equals 2x plus 4 on the coordinate plane, which will represent our battlefield in this problem. Our second step will be to choose a test point. I chose 0, 0 because it is not included in the boundary, and then you plug it into the equation. This gives us 0 is greater than or equal to 2 times 0 plus 4, which, through simplification, becomes 0 is greater than or equal to 4. This is a false statement, so our test point, 0, 0, does not work in the inequality. In this case, we will shade the half-plane that does not include 0, 0. This shaded half-plane and boundary include all solutions of y is greater than or equal to 2x plus 4, showing us exactly where the enemy is located. But this is only the first part of the mission. Let's move on. Our next problem discusses the amount of tools you can purchase with a specific budget. In problem 2, the chart shows prices for smoke bombs and kunai. You can only spend $50 in both. How many smoke bombs and kunais can you purchase? Looking at the chart, smoke bombs cost $5 each, and kunai cost $10 each. Our first step is to write an inequality describing this situation. We know that the price of smoke bombs plus the price of kunai has to be less than or equal to our budget of $50. For the inequality, we will let x equal the number of smoke bombs and y equal the number of kunai. This information, put together, gives us 5x plus 10y is less than or equal to 50. This is because 5 times x will give us the cost of x kunai, plus 10 times y, which gives us the cost of y kunai, must be less than or equal to $50, our budget. Our next step is to determine a boundary line through finding the inequalities x and y intercepts. To find the x-intercept, have y equal 0 in the inequality. This gives us the x-intercept of 10, which we will graph here. Next, we have x equals 0 to find the y-intercept, which, through simplification, we find is y, which we will plot here. We next graph the line that intersects 10, 0 and 0, 5. We use a solid boundary line because 5x plus 10y is less than or equal to 50. Finally, we must shade in the half-plane that represents the ratios of tools we can purchase. Because the number of tools you can purchase is finite, you cannot purchase infinite tools, so you shade the region below the boundary, because the region above the boundary would represent infinite tools purchased, which will not fit in our $50 budget. The number of smoke bombs x and kunai y are whole numbers. In math, such a situation is called discrete. Only whole number points in the shaded half plane can represent possible combinations of tools you can purchase. Solutions on the boundary line represent combinations of tools that cost exactly $50, such as 0.5, and those inside the shaded region but not on the boundary line will only use a portion of our $50, such as 1.2. This means that if we say buy exactly 5 kunai, or 10 smoke bombs, we will use all of our $50, but if we only buy 1 smoke bomb, or 1 kunai, we will have change left over. Now, let's look at problem 3. Your attack plan is represented by the inequality y plus 2 is greater than the absolute value of x minus 3. Graph this on the coordinate plane. We'll be working with an absolute value inequality, which, yes, may seem daunting, but don't fret. You can graph a two-variable absolute value inequality much like the one representing your attack plan, in the same ways you graph linear inequalities. Now then, let's start by solving the inequality for y. Solving for y will give us the inequality y is greater than the absolute value of x minus 3 minus 2. Do you remember transformations? If not, the new inequalities boundary will be the graph of y equals the absolute value of x, translated to the right 3 units and down 2 units. The boundary will also be dashed because the inequality is simply y is greater than the absolute value of x minus 3 minus 2. In this problem, we will shade the area above the boundary because the inequality tells us that y is greater than the absolute value of x minus 3 minus 2. And the shaded area will represent all possible solutions to the inequality y is greater than the absolute value of x minus 3 minus 2, which is our solution. Or, in this case, the areas we will be stationed to attack. Lastly, while you were scouting, you discover a new map of the enemy's attack plan, but all there is a graph. What inequality can be used to describe this map? First, we'll use transformations to write an equation of the boundary. This is the graph of y equals the absolute value of x transformed 2 units to the left and 1 unit up, and also reflected over the y-axis. So it can be written as y equals negative absolute value of x plus 2 plus 1. Our next step will be to determine the sign to make this equation an inequality. The boundary is a dashed line, and the shading is above the boundary, so the inequality must be that y is greater than negative absolute value of x plus 2 plus 1. So, our solution in the inequality that describes this graph is y is greater than the negative absolute value of x plus 2 plus 1. Now then, it's time to test our skills in attack. Pause the video to answer the following problems before the answer appears and record your score. Also, remember, you can always go back through the video if you have any questions. Let's do this. Time to finalize our attack plans. Graph the following equations. Below are the solutions to the problems. It looks like the enemy had a change in plans. Write inequalities to represent the following graphs. The solution to the first problem is y is less than negative x minus 2, and the second problem is y is greater than or equal to the absolute value of x plus 3. The time it takes to take over an enemy fort depends on how many enemy troops are stationed there. It will take up to 20 minutes per troop for a fort with up to 6 troops, and up to 15 minutes per troop if more than 6 troops are stationed at the fort. A. Write 2 inequalities to describe the time it takes to take over a fort. 2 inequalities that describe this are y is greater than or equal to 20x if x is less than or equal to 6, and y is greater than or equal to 15x if x is greater than 6. Now, graph these inequalities. The graph of y is greater than or equal to 20x is here, and the graph of y is greater than or equal to 15x is here. So, now it's time to tally up our scores and see how we did. If you got 7 or 8 questions correct, great job! You have mastered this topic and are ready to move on. If you got 5 or 6 problems correct, not bad. Let's really focus on mastering the material and review what you got incorrect before moving on. If you got 2, 3, or 4 problems correct, you're probably a little confused, but don't panic. Just review the video some more and try again. And if you got no problems correct or 1 problem correct, this may seem overwhelming, but let's watch the video again and really follow the examples. I know that you'll be able to master this. Well, that's it for today's Ninja Math. I hope you had fun and learned lots.